Let's get into the good stuff. Soft liquidations, featuring Boa's anchor mechanism. As always, we're going to encourage you to check out the prior 4 videos. They cover how we set up Boa, how we launched all these contracts, and we've just gone ahead and squashed everything into a single file to make it a little bit quicker. But we would urge you to go through the full guts in case you're confused about how we set anything up, or to pop in the comments and ask questions. So for this particular Jupyter Notebook, we are, for you, setting up some approvals so we don't have to deal with approvals. We're taking CurveUSD and our ViperWiff hack collateral token, and we are approving max 2 to the 256 minus 1. And as a sanity check, make sure that you have one loan already in our ViperWiff controller. We've also created some helper functions for you. The first one's pretty self-explanatory. We're just looking at the user balances for the CurveUSD and the collateral token. But the second is where we're really showing off the advantage of why you might want to use Boa. Boa plays nicely with Jupyter Labs, and Jupyter Labs plays nicely with charting libraries like MATPLOTLIB. So this is a function that we've created that's going to show off what our collateral for this user has been deployed at within a vault. You can see that we set up a loan at the riskiest possible. This is just 4 bands of collateral. We took 100,000 tokens, spread it out into 25,000 tokens per band, and squashed it almost up against the current price. The current price is $1. So this collateral is deployed from 99.5 to 99.9 cents. In order to do this, we called a few of the functions within the AMM contract, which was deployed as this suite of deployments related to our vault. We're looking at the active band, that's where the vault is currently available for trading. We're figuring out the user's tick numbers. That was where we saw that they were in bands 1 through 4 to be able to basically display this. And we got the boundaries of these ticks by using the p oracle down and p oracle up function, and use the bands y function to figure out how much collateral exists within that band. So this is pretty similar to the Curve UI. The difference is in the Curve UI, it goes the extra mile of showing you what percentage of any individual band is in collateral, which is in stablecoin. But as we go through, we're just going to show the total proportion of collateral that's being traded into and out of this. So let's show off how to do a trade. If you've done any work with Curve pool trading in the past, you'll know that one of the important things that you'll do before you actually trade in the pool is calculate how many tokens am I going to get out of this. There's always a get dy function. So a trade is swap x for y. Get dy says what's the change in y going to be for any amount of x that I put in. So if our x value is 10,000 CurveUSD, we're going to find out as we go from 0 to 1, what's the y val that we would get out. In this case, given the current prices, given the current balances of the AMM, it's willing to trade 10,000 CurveUSD and give back 9,971 collateral tokens. We say, okay, that's a fair trade. Let's go ahead and do it. The only difference when we actually run the exchange function is we are going to pass this 4th parameter, which is the slippage tolerance. We're taking this y value. We're saying we're willing to take 99.9% of that, in other words, 0.1% slippage. And if this is the case, let's see what our first and final user balance is and show the result. So we've indeed taken 10,000 tokens, and our collateral has gone from 89.9 to 89.909. And you can see accordingly about 10,000 tokens have been drained out of band 1. This is the soft liquidation mechanism. The only difference is when it's real tokens on the line, here you're buying collateral tokens, and maybe you have in mind that you're going to take those collateral tokens and trade them into the LP pool where you're getting a better price for it. So you might take these tokens and say, all right, I can pay these in the pool and get more than 10,000 tokens out. So it would actually be profitable for you to make the trade. This is where the get dy function would tell you if the token trade is actually worth it. Imagine you just wanted to simulate the trade, because maybe you're not exactly sure if the pool is going to work properly. We're working against a forked mainnet, so we can actually just play with the state of the chain all we like. We did this in Brownie a lot. We would time travel, so we'd run some code, and then we'd go back to a previous marker. If we want to do the same thing here, we can use the boa anchor function. So first we'll just again use get dy to say if we're trading coin 0 curve USD to coin 1 collateral token, what can we expect? And then from there, we'd actually just like to test this trade. Boa uses the anchor function to handle this. The anchor function kind of sets a snapshot, and then anything within the indented block of code, it will execute, but then when the indent ends, it's going to revert back to that anchor point. So it's a pretty elegant way of doing this. It makes a lot of sense. It's very Pythonic. You can see in the example here, it's incrementing a value, and then when it's done, it's reverting. Exactly what we need. So we're going to show off running a trade the exact same way. So that would be with boa.env.anchor. We will run this block of code and we'll trade another 25,000 tokens. And this has given us, it's eaten into all of band 1, and we're now on to band 2 is now the active band. Our ending balance of curve USD has gone from about 88K down to 63K. Our collateral shot up by almost the same amount. But then when we run the user balances function here, this next cell, we find out that everything just reverted back to the way it was. We still have 88K curve USD and 89.9 collateral. Great for simulating results. You can imagine how this can be very useful. And finally, of course, this works just the same the other direction. If you'd like to trade your tokens back into the AMM and take out all the stable coins that exist, you can again call the amm.getDy function, except in this case, instead of trading from coin 0 to coin 1, you're going to trade from coin 1 to coin 0 and see if it's worth it to you. In this case, it's kind of a bad trade because you're trading in 25,000 collateral tokens and getting back 10,000 curve USD. So this would be a bad trade. You probably could have just traded the 10,000 tokens in. This is where you might have wanted to use the getDX function, which is saying how much given an X, how much X would I need to put in to get out 10,000 curve USD tokens? But all the same, this has done a good job of reverting this pretty much back to the original state. The only difference is that we are a little bit shorter on the collateral, but we're pretty close to back to the original curve USD. And now the collateral is distributed across 4 bands. So we've showed off a lot in this unit. We've showed off how you can basically manipulate the state of the chain using the anchor function. And we've showed off how you can chart the results nicely using MATPLOTLIB and Jupyter Notebook. If you got any questions, do drop them in the comments. Make sure to stay safe out there, but at least now you know the basics of soft liquidation. Next unit, we're going to get into harder forms of liquidation, so stay tuned.